All right, future engineers, welcome. We're going to jump right into a course that's a huge part of your second year, DMS 4010, Sensors and Instrumentation. So let's pull back the curtain and see what this course is all about, why it matters so much, and what you're going to get out of it. Okay, so here's how we're going to break this all down. First, we'll cover the basics. What exactly is this course? Then we'll walk through your learning journey step by step. After that, we'll connect it to the bigger picture of your engineering skills, look at how you'll actually learn all this stuff, and wrap up with the all-important details on how you're graded. So, first things first, what is this Sensors and Instrumentation course really? And maybe more importantly, why is it a mandatory part of your engineering education? Let's find out. At its absolute core, this course is about how we give machines senses. You know, how does your phone know when you turn it sideways? How does a smart thermostat know the temperature? It's all because of sensors and transducers. These are the little devices that act as the eyes, ears, and, well, the nerve endings of all our modern tech. They're the bridge between the physical world and the digital one. And let me be super clear about this. This is not an elective. It is a compulsory core subject for every single one of you. That's a huge signal, right? It means this knowledge is considered absolutely fundamental, no matter what kind of engineer you plan to become. So the whole point here is to give you a complete toolkit. You're going to learn exactly how different sensors work, figure out which ones to use for any given job, understand how to actually make them work, and even get a glimpse of what's coming next in sensor tech. Okay, let's move on and look at the curriculum itself. You'll see how it's designed to take you from the very basics all the way to a solid level of understanding over the semester. The course is laid out as a really logical 5-step journey. We start with the absolute basics. Then we get into how you can model sensor behavior with math. From there, you'll dive into the huge variety of sensor types out there. After that, we'll cover instrumentation, the circuits that power them. And to wrap it all up, you'll learn how these things actually talk to each other and to other systems. And when you complete that journey, you're going to walk away with these 4 really critical skills. These are the official outcomes. So this isn't just about theory. You'll actually be able to pick the right sensor for a job, make sure it's giving you accurate data, and figure out the best way to get that data where it needs to go. Now, this is where it gets really cool, because this course doesn't exist in a vacuum. It's designed to be a major building block for you as a professional engineer. Take a look at this quote. This is pretty much the mission statement for your entire engineering degree, and this course gives you the tools to actually do it. I mean, think about it. How can you design a creative solution if you can't even measure the problem you're trying to solve? That's what sensors let you do. And you can see right here how this course plugs directly into those high-level professional skills. Problem solving? Check. Creative design? Absolutely. Using modern tools and getting ready for a lifetime of new technologies? It's all baked right into the course. Okay, so we've covered the what and the why, but what about the how? How are you actually going to learn all this stuff? Well, it's a mix of different approaches. Let's look at the workload breakdown. Now, you'll see a big slice there for self-study, and that's important, but look at the other pieces. There's a serious amount of time dedicated to hands-on lab work, interactive sessions, and assignments. So this is definitely not just a sit and listen kind of course. You're going to be doing things. And that lab work is where it all comes together. It's where theory becomes reality. You're going to get your hands on actual hardware, things like linear variable differential transformers and strain gauges. You'll see for yourself how they work and really connect what you learned in the lecture to how they perform in the real world. Okay, let's talk about the bottom line, grades. It's super important to understand exactly how all your hard work is assessed, so let's demystify the grading strategy. The formula couldn't be simpler. Your final grade is split right down the middle, 50-50. Half of your mark comes from all the work you do during the semester, and the other half comes from your final exam. Nice and balanced. Now, if we zoom in on that first 50%, your continuous assessment, you'll see it's also split 50-50. Half of that mark comes from your tests, and the other half comes from all your practical work, like your lab reports and assignments. And please, this is probably the most important slide in this section, so listen up. To pass this course, you can't just do well in the final exam to make up for your coursework or the other way around. You have to get a mark over 40 in both your continuous assessment and the final exam. They are 2 separate hurdles you have to clear. So there you have it. DMS 4210 is way more than just another required course. It's a skill set. It gives you the tools to see, measure, and interact with the physical world in a whole new way. It's foundational. So the only real question left is, what problem are you going to solve first?